Welcome to the video on limits by factoring. In this video we're going to learn how to use factoring for solving limits. We're going to talk about the idea behind it, and we're going to solve 3 examples step by step. Limits by factoring is the first technique for solving limits that it is not simply replacing the value of the variable by the value it is approaching. For example, let's try to do that in this problem. Here we have the limit as x approaches 2 of x squared minus 4 over x minus 2. If we here replace x squared by 2 squared, we'll get 0 here in the numerator. And here below we'll get 2 minus 2, that's 0. So if we replace 2, our function is indeterminate. We get 0 over 0, and that symbol is not defined. That's not a number. So you may think that this limit does not exist, but we can apply we can apply algebraic techniques for simplifying this expression, and one of those techniques is factoring. In this case, we can factor the numerator like this. We can write the numerator as x minus 2 times x plus 2, and then we can cancel the x minus 2 here with the denominator, and we simply get this limit, the limit of x plus 2. And now we can replace x by the value it is approaching, that is 2, and we get that this becomes 2 plus 2, that's 4, and that's the answer for this limit. So let's think about what is happening here behind the scenes. What is the graph of this function here? If you graph this function by hand or using a computer, you'll get a straight line like this one. But the detail here is that this line has a hole at the point x equals 2. That's because the function is not defined at that point. You get the impression that if it were defined, the function, the value of the function at that point should be 4, but it's not defined. That's because the graph of the function is the same graph of the function x plus 2, but with this hole here at x equals 2. So let's see another similar example. Here we have the limit as x approaches 1 of x cubed minus 1 over x minus 1. Here we can factor the numerator. You remember how to do that? You factor this as x minus 1 times this polynomial here. We can factor the x minus 1 and we get this limit of a polynomial. And for this type of limits, we can simply replace x by the value is approaching 1, and we get this equals 3. That's the answer. So this was very similar to the first example, and if you graph this function, you'll get the graph of this polynomial that is a parabola, and the idea is the same as the previous one. The graph of this function will be a parabola but with a hole at x equals 1. And what is behind this technique is the idea we talked about before, that when you're taking a limit of a function, it doesn't matter what is the value of the function at that point. You're only interested in what the function is approaching at that point. So let's solve another example. Here we have this limit. Here the variable is h, is approaching 0, and we have this quotient here. So here a is a constant, so we can expand this term like this. This is the expansion of this term. Now we can cancel the a cubed. We get this expression. Now we can factor the h in the numerator like this. Can cancel the h, and we get this polynomial. Now, as before, we can replace the h by 0, so we get that this will be 0, this is 0, so we get 3h squared, and that's the answer. So this is just, you see that all the examples were pretty similar. You only need to apply a simple algebraic technique. Here we needed to expand this term before applying the factoring technique, but it is the same idea. So you see that you can use any algebraic technique that you already know to solve limits. So that's all for now. Thank you for watching, and see you next time.